Hello and welcome to part 2 of our 2D platformer tutorial. In case you missed part 1, there is a Unity package available for you to download on our GitHub. So in this tutorial we'll be covering a couple things. We'll be going over Cinemachine and how that's a very useful module to implement advanced camera motion. But in this case we'll be going over some of the fundamentals of Cinemachine. Second, we're going to be showing how to implement destructible tile maps. Then we're also going to go over how to implement player attacking mechanics, as well as animating the player getting hit by an enemy. So to start off, we'll be going over Cinemachine. Cinemachine isn't currently installed, so you can install it by going to Window, Package Manager, and then under the Unity registry, you should see Cinemachine. I'm going to install this package. And after you've installed the package successfully, you should be able to see a tab called Cinemachine right up here. So the way the game is currently set up, we have the main camera attached to the player. So if I click play, we notice that no matter how we move, whether we jump, the camera will remain centered on the player. The player remains in the center of frame, right? And what if we don't want that behavior? What if we would like a camera that maybe tracks the player a little bit, behind? Maybe it lags a little bit. What if we want the player not to be centered in frame? So the way we can fix that is use Cinemachine. So I want to click on the Cinemachine tab on the top of the Unity editor and click Create 2D Camera. This will do two things. One, it will add a Cinemachine virtual camera, which we'll be editing in this part of the tutorial. It will also add a Cinemachine brain to the main camera. So the Cinemachine brain essentially allows you to control the behavior of multiple virtual cameras. So let's say I wanted a camera that perhaps tracks the player, and maybe another camera that is our cinematic camera, which has a specific behavior that's different from the camera that we're attaching to the player. The Cinemachine brain allows you to switch and blend between multiple Cinemachine cameras, and it's a quite useful setting. And so to start off, we'll just be using one Cinemachine camera. And so let's click on the virtual camera right here. And then under follow, we can drag our player. So once we do this, you should see this overlay on the game view. You won't be able to see this on the scene view. So make sure you're on the game view. The first thing you'll notice is that we have a yellow dot at the center of the frame that's attached to the player. So if I click play, you'll actually notice that the behavior of the camera is slightly different. So there's a little bit of time, right, that the camera takes in order to catch up to the player. It's no longer trying to center the player immediately. There's a little bit of lag. So I can move to the right of center of frame or to the left of center of frame, stand still, and the camera will try to catch up. And so this is due to damping. So if you go onto the virtual camera right here, we can reduce the damping values, which means that the camera will instantly try to update itself to where the yellow dot is, right? So if I put it at 0, you can see it's basically behaving like how our original camera was. However, if I increase the damping values, the camera lags behind and takes more time for it to catch up to the center of the player. So that's what damping values do. And you can configure them to your liking along the X and Y axis. We won't really need the Z axis right now because we're only moving in 2 dimensions. But that's what damping values are. Okay, so I'm going to reset these to 1. Another setting to go over would be screen X and screen Y. So this will determine where in frame the follow target should be. So the way screen coordinates work is that the top left of what you can see on the screen is 0, 0. As you can see, the yellow dot is on the corner of the screen. And then as we go to the bottom right, we move like in this direction, that's +1 in the y-axis, and if we move to the right in this direction, that's +1 in the x-axis. So if we want to position the camera at the bottom right, we can just do 1, 1. And if we want to position the camera at center of frame, that'll be 0.5 and 0.5. Okay, Another setting we can use is look ahead time. And so what look ahead time will do is that if an object is moving really fast and we'd like to predict its movement and try to track it, we can increase the look ahead time, which will take into account the player's velocity. So for example, if I start falling right here, right, the player is moving so fast that essentially the camera doesn't have enough time to be able to correct its movement to the center of the frame because its position has already changed. So one thing we can do is we can increase the look ahead time, and this will essentially try to predict where the player is moving such that it can correct its position to the center of the frame. Okay, so another setting I want to go over is dead zone. So if right now our dead zone is set to 0 on width and height, but if we set it to a non-zero value here, you can see we create this little box where the blue, aka our soft zone, isn't filled. And so what this means is that when we move within the non-colored area, the camera won't update. However, if we move up and we move into this blue area, which is the soft zone, this determines how the camera will move such that it corrects, such that the player is back within the boundary of a soft zone. So for example, if I'm in this dead zone right here, and if I'm in the soft zone, the camera will try to gradually reorient itself to the nearest boundary of that soft zone. And so let's actually play with those values right now. So I'm going to, let's say, remove this soft zone right here. So if we have no soft zone, right, then the camera is essentially going to not have any damping attached to it. It will just immediately update itself. If we set the dead zone width and height to 0, and let's just increase the soft zone right here, I can move anywhere within this blue box such that the camera will reorient itself to the screen X and screen Y position, right? So we set this to be the center, and so as we move, as long as we're in the soft zone, the camera will try to correct itself to that screen X, screen Y position, right? So if I moved here, right, the camera wants to correct itself such that it's in this intersection right here, and that's what will happen. So let's slow down the damping values. And there you go. And so that's a quick introduction into Cinemachine. You can do a lot more with this, but this was just to show some of the fundamental settings, some of the settings that you'll be most likely using. There are many different types of cameras in Cinemachine. This was only a 2D camera, but you can have state-driven cameras, free-look cameras that work for 2D games, 3D games, cinematics. Cinemachine is a really great module that allows you to interface and implement complex camera behaviors with minimal coding. So it's a great package and I highly recommend it. And I'll pass it off to Richard to go over how to implement destructible tile maps.
Let's create a new 2D object tile map, rectangular, underneath the grid game object. And let's call this destructible. And if you go to Window, 2D, and Tile Palette, you can open up the Tile Palette window. I'm just going to drag it down here and going to paint a few tiles into our new destructible tile map, making sure it's the active tile map when you're painting. And then I'm going to close the tile map palette. First, we need to remember to change the order and layer under the tile map renderer, so our destructible tile map will show up over the background. Then we need to add a tile map collider 2D, check the used by composite box, add a composite collider 2D, and set the rigid body generated by the composite collider 2D to be static. So now if we play our scene, we should see that this new destructible tile map, although it's not destructible yet, behaves like our regular platforms. Oh, actually, first, we do need on our destructible tile map to tag it as ground so that our player can jump on top of it. Okay, now it should act as our regular platforms do. Okay, so now to implement the destructible behavior, we're going to create a new script and attach it to our destructible tile map. I'm going to call my script destructible tile map. Let's double click this and open it. And the first thing we need to do is to create a reference to our tile map that's attached to the same game object as the script. So we can have a private tile map. However, we do also need to do using Unity engine.tilemaps so that Unity knows what a tile map is. And inside of awake, which is like start but happens even earlier than start, we can set tile map equals to get component tile map. So this will get the tile map attached to the same game object as the script. So to implement the destructible behavior of this tile map, we're going to use the tilemap.setTile function. This function takes in a position, a vector2 position, which is the position of the cell within the tile map that should be that we want to change, and then a tile type, basically. In this case, since we want to change from an existing tile to no tile, we can just pass in null to delete the tile. So we want to delete these tiles when something collides with our tile map. So we can use the onCollision enter 2D function to check which tiles we need to delete and delete them when something collides with our tile map. So this takes a collision 2D, and we can just call it lowercase collision. And then, so let's type out some pseudocode for this first. So we want to iterate over each contact point, or basically where each point where something is colliding with our tile map. And then for each of these, find the position of the tile being contacted, and then delete that tile. So to keep track of although we could create a new vector for each position, I'm just going to create this vector3 tile position outside of the for loop, and we can set it to 0 for now. And then so for each contact point 2D, and then I'm going to call this contact in collision.contacts. We need to set the tile position .x and tile position .y. The .z can stay at 0 because our tile map is 2D. So first, let's set the tile position to collision or contact.point.x and contact dot point dot y. And then to delete this tile, our position is, we can use the tile map dot lowercase tile map dot world to cell and pass in the tile position. So this will convert the tile position in our 3D world space to the 2D position inside our grid, tile map grid. So the tile map knows which tile to delete. And then again, use this tile map dot set tile. In this case lowercase, because we want to delete the tile from our tile map reference, and null to set it to delete it. However, if you let this compile and play the game, there will be a slight issue in which sometimes it will choose the wrong tile to delete. This is because the contact points are all on the edge of the collider, so sometimes it will, if it's right on the edge, you don't know whether we should delete the tile that's like slightly above or slightly below the contact point, or slightly to the left or slightly to the right of the contact point. So we need to add a very small offset. So let's call this, let's add a private float offset and just set it to like a small number. Any will work. I'm just going to use 0.01, and then add this offset times the contact.normal.x and contact.normal.y. So the contact.normal is basically the vector that's perpendicular or orthogonal to the contact. So to the surface at the contact point. So this will let you offset a little bit into the tile that's being contacted, so we can get the correct position of the tile via world to cell. So now if we go back to our game and allow this to compile, we should see that when we touch the tiles, they get deleted. And when we touch the when the goblin touches the pig touches the tiles, they also get deleted. Also, why am I not jumping? Okay, there's a slight bug here with the jumping, but we're just going to ignore it because the next thing we're going to do is probably going to fix this. So having destructible tiles is great and all, but if we want to have a platform that you can walk on, obviously the tiles can't delete themselves instantly, otherwise we won't be able to actually walk on them. There'll be nothing to walk on. So let's go back to our script, and this time we're going to add a slight delay between the tile contacting the tile and deleting it. So we're going to do this using the power of coroutines. Coroutines are a very powerful type of function in Unity, which allow you to pause the execution of the coroutine and then return to it later. So let's create a coroutine called delete tile delayed. And this can take a vector to, actually let's take a vector 3 tile position. And coroutines always return a type of object called an IEnumerator. It's not very important what an IEnumerator is, but just to use coroutines. But if you want to learn more, you can read the documentation on the Unity website, or listen to our advanced track Programming Essentials workshop to learn more about coroutines. So in this case, here in delete tile delayed, we're going to yield return new wait for seconds, and we also need to set a delay. So let's use a serialize field private float delay, and we can set this to like 1 second by default. And then we want to wait for this delay, and then we do this tile map set tile thing. And then yes, and then here instead of deleting it, we call our coroutine. Except coroutines, instead of being called like delete tile delayed like this, we need to wrap it using we need to use a wrapper function here called start coroutine, and this will start this coroutine, and then Unity will see yield return new wait for seconds, which means it will pause this delete tile delayed function for 1 second, and then while other things in the game are running, it will continue running those things, and then after approximately 1 second, it'll return to this and then delete the tile. So if we play our game now, you should see that after approximately 1 second, okay. After approximately 1 second, the tiles you touch are deleted. However, you might notice even though I'm standing on this one, this tile isn't being deleted because I didn't enter the collider again after this one. This tile was deleted because I ran across from one tile to the next, so then I never exited and therefore never entered the collider again. To fix this issue, we can we also need to call this function in on collision stay 2D, which also takes a collision 2D. I'm just going to copy and cut this into and put it in its own function. So void trigger deletions. And then we can call trigger deletions in both on collision enter 2D and on collision stay 2D. Oh, and we also need to provide the collision to this function. So now if we try to run over this platform, you should see that, okay, I don't know why this jumping thing is glitching out. Let me just delete some of these tiles. Okay, now that works just fine. Okay, yeah, so if we try to run over these tiles, you'll see that they'll get deleted as you run over them instead of only deleting the first one. And that concludes our section on destructible tile maps.
All right, now I'm going to go over how we make the player take damage and knockback when they touch the enemy, and also how we can get the player to attack. And so both these, how we're going to do it is going to involve editing the player movement script that we made last tutorial. So if you haven't, you should watch our part 1 of 2D platformer tutorial, and then you'll see how we made the player movement script that I'm going to be starting out with right now. So first thing we'll do is open up this player movement script. Here is everything that we have currently, just to let the player move and jump. And so the first thing we're going to want to do is add in a few variables. So the first thing we're going to do is a private variable. It's going to be called moveLock, Boolean. And this is what it's basically going to do is we're going to use this to make it so that the player isn't able to like do anything with their input when they're being knocked back by the enemy, because that could like mess with things, and it makes it simpler. And so we're just going to not let them move when they're knocked back, and we'll use this to kind of do that. And that'll involve changing some of the stuff from last time to just not work when move lock is true. And so then we're going to have a public int called health. And this is just going to be the health of the player. We're not actually going to do anything with that in this tutorial, other than just like subtract it when they get hit by the enemy. But you could obviously do something with like adding a UI or making the player die when it gets to 0 or something like that if you really want to. And then we're going to have two floats called knockback x and knockback y. And these are going to be used to set the amount that the player is knocked back from the enemy. So first we should initialize the health. I'll just initialize that. Actually, I'll initialize that directly in the Unity editor. So all I really need to do here is just set move lock equals false, because at the very start, we want the player to be able to move, obviously. So we are going to change this onMove function and this fixed update function later, but for now, I'm going to get first into the onCollision enter 2D function, since that is the main thing that we're dealing with. Since obviously what we're trying to do is when the player collides with the enemy, we're going to make something happen. So we need to edit the onCollision enter 2D function. And how we're going to do this is if collision dot GameObject.tag equals enemy. So if they collide with the enemy, just like how we did it before with if they collide with the ground. And so what we're going to want to do is first, obviously, we'll minus their health since the player is going to be taking damage. Then what we're going to do is we're going to get a direction. This is going to be the direction of the player relative to the enemy that it collides with. And so we're going to need to obviously get the enemy position. So we'll get the transform dot position dot x. We only care about the x, since either way we're going to make them bounce up. Just because that's how we'll do it. And so we're going to do that if that's greater than rb.position.x, which is going to be the player's x position. If that's true, we're going to want to have it -1, because that means that the player is to the left of the enemy. So we want the player to bounce to the left. And if that is not true, we're going to set it to 1, because we want the player to move to the right. And then I'm just going to set these both horizontal equals 0 and vertical equals 0, just in case we don't want them to have value from the movement function and that to get in the way of anything. Then we did move lock, and so I said we want to make that so they can't move when they're being knocked back. So we'll set move lock to true. And then we're just going to directly change the player's velocity. There's other ways that you can make them move, but this one works fine for how we're doing it. So we're going to set that equal to a new vector2, and it's going to be knockback x times the direction, and then knockback y in the y direction. So oops, like with equals, that's what was being weird. And then the next two lines are going to be stuff to do with the animator that we'll deal with after. So I'm just going to set animator dot set bool is jumping false, and this will just make it so that if the player was in the air from a jump when they got hit, they won't play the jump animation. And set bool hit, this is going to be the boolean that we'll use to see if the player has been hit. We'll set that to true. The player has been hit. And so that's everything that we're going to do in the onCollision enter 2D function. Basically just when the player collides with the enemy, all this stuff needs to happen. Now we need to deal with what the move lock is going to do, right? And so what we want it to do is make it so that the player input doesn't do anything. And so I'm just going to get this whole onMove function and just say if not move lock. So if move lock is false, then we'll do what this function says. Otherwise, we just won't do anything here because we don't want them to be able to do any input. And then we don't want to be setting the player's velocity to something else when they're being knocked back, since we set the velocity when they're being knocked back to what we want it to be. So for here, I'm just going to also do if not move lock. That way, if move lock is true, the velocity is going to stay how it was with when we set it on the on-collision under 2D. So that's everything to get move lock to be to lock the movement as we want it to do. But now we need a way to make move lock set back to false, right? Because now it's going to get set to true when they collide, and then it'll never get set back to false. So we're going to make a function down here, a public function, because we're going to be calling this later as an animation event. It's not going to return anything. It's a void function, and I'll just call it end hit. And all that's going to do is we're going to set move lock equals false, since we're no longer locking the movement. And then I'm going to end the animation for the hit animation. So animator dot set bool hit false. That way, that animation won't trigger again after the animation ends, because as I said, we're going to be using this as an animation event on the end of the animation. So we don't want it to keep like replay after that. Okay. And so that's everything that we're going to be doing in the player movement function for the player taking knockback and damage from the enemy. So now what we need to do is actually make the animation stuff that we had been dealing with in the code. So once it's done loading, do that. Okay, so the first thing is we will go to the Kings and Pigs folder, the Sprites folder, the King Human folder, and we have this one here that is hit. And so what we want to do, and this stuff is the same as in our last tutorial, so I'm going to go pretty quickly through it, but we're going to set it to multiple. We're going to set it to point no filter. It might have been at bilinear before. Make sure it's at point no filter. And then we're going to do Sprite Editor. We're going to do Slice, and we will do grid by cell size. And these sprites actually, I don't know if you saw it, but oh, here, yeah. The name is actually giving us the dimensions. So I'm just going to set it to 78 by 58. I'm going to slice it, and that gives us this. We'll just apply that. And then that's good. Now we can see that we expand it out and have this. So in the animation window, make sure we're selecting our player. We'll do create new clip, and we'll call it hit. Save that. Now we'll drag these into it. I'll extend out a little bit to 0.2 seconds. And actually, because this animation is just 2 frames and it's really short, I'm actually going to add it in to play it twice maybe, just so that it might be more easily visible. Just because when I tested this earlier, it didn't really, oops, I'm not sure that's evenly spaced. I didn't like how it looks with just it just happening once. So this will take a full second, but we'll see if that looks bad afterwards. And so for now, that's all we want, except then we want to add this animation event. This is going to be the end hit function. You can find it up here, end hit. Make sure it's synced up with the end. Actually, I do think these are a bit too spaced out. I'm going to make it, I'll try half a second. So that is the full hit animation. You can see it playing out maybe. If you go like this, player just kind of flashes. That's everything we need to do there. And now you can see we have this hit state in our animator for the player. Make sure you click on the player and have the player as animator. So now we want it from any state to be able to transition into hit, because it could be doing anything when it gets hit by the enemy, and we want that to take priority over whatever's happening. So we'll make this transition from any state. All right, sorry about the technical difficulties, but now we'll add this parameter that we had earlier, the Boolean hit. We'll add that, and we'll make this transition happen. First, we'll have it not have exit time and drag that so it's closed. And then we will make it so that it happens on when hit is true. And then we want to do this. We go in settings and do can transition to self. We want to set that not to true. That way, if the player, once the player gets hit, it will go to this hit state and the hit Boolean will be true. And then it'll go through the full animation, reach the end, and get to the part where the animation event turns hit to false, and then end this animation. Whereas if we don't have this, the hit boolean will be true, so it'll keep B in the hit state, and then when the hit boolean goes on, it'll go to the hit state, and then it'll keep going to the hit state and never run through the hit state, because this any state transition will keep happening as long as hit is true. And so we won't get the animation event to end it, and so it'll just keep going forever. So we want this to exit the hit state once it's over, and so we'll just add transition, regular default transition to idle. That's everything to get this to be working. So now let's run it and see if that works. I forgot to set the knockback, so that's why the player is not moving. So I will just set that right now. I'll set the health to 3, not that it will really do anything. Set this knockback to 1.5 and this 2, just see if that works. If not, I can always change it. That does work. One thing that I should do is actually make this transition to jump from any state. We want this to not happen if the player is hit. That way it does the getting hit rather than the jump. And so that should fix why it was looking a little weird down there. So I'll run this one more time. See if that does indeed fix it. And see, that does seem to be better. And as I said, like with the animation itself, I could make that look a little nicer. But for now, it seems to be working fine. So there's no need to really fix it. And you can see if I'm on the other side, it knocks me back to the other side. And that's what that direction part of the movement function for doing the knockback, how that works. And so now we have the player is able to be hit. Now, what if we want the player to be able to hit back and use an attack? So to do that is again going to be changing the player movement script and adding an animation. And this time, just to switch it up, I will actually do the animation first. And so we're going to want to go back into our Kings and Pigs Sprite folder, the King, 01 King folder. We have this one for attack right here. So we're going to want to do the same thing where we set this from sprite mode single to multiple. The filter mode, it might by linear. If it is, set it to point no filter. If it's point no filter already, just that's fine. And then we're going to do Sprite Editor. And we'll slice it. Again, we can grid by the same 78 by 58 as it says in the name for the sprite. Oops, need to apply that, slice it. So we'll apply that. Now we have the sprite slice, so we can see it like this. And now we're going to want to do the same thing where we make sure you click on the player, create a new clip, attack, drag these in. I'll make it take half a second. We can mess around with that later if this doesn't look super nice. And so now we have that the player is able to do an attack. But now we want it so that the player actually has a hitbox for this attack, right? We don't want the player to just do the attack. We need it so that there's some way of knowing if the attack collides with the enemy. So what we're going to do is we'll add a component. And since this attack looks pretty much just like a circle, I'm just going to use the circle collider 2D. If your attack was different, like maybe like a sword stab or something, you could do like a box collider or composite collider if it's some weird hitbox. But for now, circle collider should work fine. And we're going to actually set this to be inactive by default, and we're going to set it to be a trigger. So we don't want it to be like an actual collision that can knock things back or whatnot. We just want it to register if it hits and then trigger something when that happens, like a function on the enemy to make it take health or something. And so that's what we're going to do there. And now to get that so it actually like goes with the attack, we're going to do in the animation window, we press this red recording button. And I'm actually going to drag this down here just so it's easier to see this next part. So in our scene, so now what this recording button does is whatever changes we make to the player, like the stuff on the player object that the animation is on, while this is effective, this recording, it'll actually do that, like add keyframes for that on the animation. So like if we set at the very start of the animation, if we set this circle collider to be active, now it adds this that enables this circle collider at the start of the animation. And so we want to, now it's active. Now we're going to want to make it so it's around the right area. So I'm going to just do this, kind of drag it a little bit around where we want the attack to be. It doesn't have to be perfect, but just kind of get it a little bit around the right area. And then see how that looks. All right, so now we have that kind of lined up with that one. And then we'll go just before this one, we'll add a keyframe. That way it doesn't shrink the animation during that time period, because if we just changed it now, it would kind of like gradually change the size. But we want it to go from this size when this sprite's like this, straight to this size. So now we'll shrink it again to fit this new animation. I'm not going to do a super good job of like fitting it just because it doesn't really matter. And we're not going to actually show the implementation of the enemy getting hit. So this is more just to show how to do this at the moment. And then we'll go right here, add a keyframe. And then at the end, this final frame, set it back to inactive so that it no longer can do things and trigger things once the animation ends. And so now we're done with that, and we can end this recording. So now we have, as you can see, it's active, it shrinks, and then it inactivates. You kind of see that it got a little fainter. So now we need to make the transitions to that. So we have in our animator for the player, we have this attack state. And again, I'm going to just do a transition from any state because we want it to be able to, from idle or running, we want it to be able to transition. And we could just make one from idle and running because we actually don't want it to be able to go from hit or jump into this attack state. But I'm just going to do it from any state in the movement script, make it so it doesn't go from the jump and hit. It just depends how you want to do it. And if you had a ton of states, it maybe is better to do it like not do individual states transitions from each of those states. But now we only have like 2 that it can transition from or 2 that it can't. So you can do it really with any state or directly from them. But I'm just going to do it like this. I'll add a trigger this time, not a Boolean. And I'm going to call this attack. And the difference between a trigger and a Boolean is that a Boolean is going to, once it's set to true or false, like once it's set somewhere, it'll stay that way until it gets set not to that, not like either not true or not false, like just the opposite. Whereas this trigger, once it's set to true, or once it's set on actually, then once the transition that uses that happens, it automatically sets it to false. So it's not, or to off. So it's not like you can keep triggering it over and over again. It'll just do once. So that's why we want to do it here. Just makes it easy to just, when they click to attack, it'll set the trigger on and then it'll do it and then it'll be off. So we don't need to worry about setting it off at the end of the animation like we did with the last one. And so now we're going to, we have that working. We're going to make a transition from here just into, well, first let's actually make sure this has no exit time and drag this closed. We don't need to set the can transition to self to false because how the trigger works, once it does the transition once, it'll be off. So it won't keep going back to this over and over again. That's fine. So now we'll just make a regular normal transition to idle from this and just keep it default. That's everything we need to do here. And now we need to go back into the player movement script and make it so that this attack works. And so for movement, we did the onMove function. And now that's because in our player input, we had the move. Now we have fire. And so we're just going to use this. It works with the mouse button. We're just going to use this along with some other buttons, but we're just going to use this to allow the player to attack since it's already there. You could add buttons or change buttons or whatever you want, but we're just going to use this for now. So we'll make a void on fire, sorry. And we don't need any variables there. And make sure it's capitalized. If it's not, it won't trigger it with the input thing. So what we're going to want to do here is just if, and I'm just going to say if it's not animator dot get bool is jumping, this is the part where I said we don't want it to happen if the player is jumping, or if the player is getting hit. And so I'm just going to check the animator. If it is jumping, we could actually probably do if the jump variable is true, but I'm just going to keep it like this because I'm not totally sure that the jump variable is going to 100% be set true when or the grounded variable. I'm not sure if that's going to be set true every time that the player is jumping. There's times when it couldn't. I think maybe when the player is being hit. So we're just going to use the animator booleans since we know the animator is working properly and exactly when we want whatever to happen happens. And so all we're going to do is set animator dot set trigger, sorry, not target, attack. And we're not actually doing, we might want to do something to check if the player hits the enemy with their attack, like maybe adding a non-trigger enter function to the player or the enemy. But we're not going to show how that works for now, just because we don't have time. We want to keep this tutorial kind of short, and we don't, and we figure it's not that much different from on collision enter, just a different on trigger enter function. So we're just making the player attack. We're not going to actually deal with the player hitting the enemy. So now that's good. That should be good. We're going to go and we'll see if that's working properly. Oops, there seems to be a problem. I didn't set this transition to happen on anything, so we need to make it so that it happens when the attack trigger is on. Now it should be working. Yep. So we see I could probably make the animation quicker, and it doesn't work when you're jumping, as we said. And if the player is going to get hit, it won't work if I click right when the player is being hit by the enemy. But if you're not, it'll work. And so that there probably would have hit the enemy, but we didn't actually implement the stuff to happen when you hit the enemy. So it doesn't look like anything's happening, but there, player can attack, player can get knocked back to the enemy. So we've taken care of all of that. Now, if you wanted to do some extra stuff, you could maybe add a death animation for the player or add some UI elements to track the player's health and make stuff happen when the player loses health. And you could also make it so that the player and enemy take damage by editing the player movement or the enemy movement script. Probably might need to do a little bit in both to deal with the triggers colliding or the trigger enter, and to deal with like changing the enemy's health and stuff like that. But that's some extra stuff that you can work on if you feel like it. And so that's everything to do with taking damage and attacking.